Hello everyone, I am Menendra Survey. So today we are going to discuss a very good quality interview questions for mechanical engineering branch and for GATE aspirants. Those are qualified for GATE exam and going to face the interviews in BARC, DRDO, ISRO or BPCL, HPCL like for IOCL, so for good quality PSUs. So this lecture series will help you a lot. So we are going to discuss an interview question on basic thermodynamics, and you can see the topic name is written over here is entropy. So entropy is a very common word, or a lot of interviewers they can ask you the question on entropy because it is it comes from physics and chemistry as well, and as per of mechanical points of view or basic thermodynamic point of view, it is a very important concept. So what will be the question, or what the question they can frame. So I have taken two cases. First case is crushed ice which is taken in the glass. Second case is a glass of water. In both the cases, which case is having a maximum entropy, or we can say having a maximum disorderness? If the question is asked like on the concept of entropy, so you should aware about what is the meaning of entropy. So if I give you three kind of examples, if ice is going to melt, the cream on the cup of a tea is, cup of coffee is going to that cream is going to melt. And the second or third example we can take, if glass is crushed. Fourth example, if we take example of air is leakage from the tire, which is air leaks from the tire, or that case we can consider. And all the four cases you can consider the entropy plays a very big role. So air leakage from that tire is also example of entropy. Ice is going to melt. So entropy is nothing but a degree of randomness or disorderness. Or we can say it measures the degree of randomness. Entropy measures how much is the molecular disorderness having the substance or that molecules. If more is the molecular disorderness, the maximum or more is the degree of randomness, and if degree of randomness is more, then we can say entropy is more. So entropy relates basic thing as nothing but your degree of randomness. So if puncture tire air is going to leaks, that is a good example. We can say the concept behind is entropy. Okay, so for these two cases, if I take two example, this is a glass with the water. The question is like that, at the room temperature, or we can say for given temperature or a room temperature, what is the entropy for this glass? And this glass is filled with the water. So these kind of questions are going to frame, or the question is like either glass or either they can ask you a bottle, because every common interview you can take a water bottle is over there and glass with water is over there. So the question is going to frame like this: what will be the what will be the entropy for this bottle which is filled with the water at a room temperature or given temperature? They can ask you the question. And the next question, they can compare or they can ask you the what is the disorderness, which case having maximum disorderness or which case having maximum entropy, either with the glass with a crushed ice or glass with a fill of with the water. So before going to discuss these three things, or before going to discuss this solution for our interview question, I am going to, we can take this example, or TS diagram. If I plot over here TS diagram, temperature entropy. So for temperature entropy for reversible process, if I am taking from process 1 to 2 for reversible process, so we know that dq by t is equal to ds. Okay, so if I write over here for process 1 to 2, or entropy for process 1 to 2, dq by t is equal to ds. So dq is equal to t into ds, and if you know this dq is equal to t into ds, or we know dq is equal to tds, or if we integrate this, we'll get q is equal to integration of tds, or q is equal to mc dt. Heat transfer or maximum capacity of heat, that is nothing but mc delta t, change in temperature. Okay, so this relation will help you to find out what will be the change in entropy for a glass or solid substance or liquid substance. We are not discussing over here in the gases test, because if you take an example of gases, there will be three various formulas to find out change in entropy or difference in entropy according to Cp, Cv, polytropic index, and so there will be three different formulas to find out what will be the change in entropy. If I want to find out the change in entropy for solid or for change in entropy for liquids, we can proceed with this expression for process 1 to 2. So area under this TS diagram will gives you this value of Q. Okay, so we can easily find out from the second law of thermodynamics, the entropy we can easily found out. So it is based on second law of thermodynamics. So Q is equal to TDS into mcdt. So this expression we can take it, or with the help of this expression we can derive what will be the change in entropy. What will be the change in entropy for these cases, glass with the water. So look at over here. If I want to find out change in entropy for this, so what we are going over here, Q is equal to mc dt. So we'll take this expression, dq is equal to tds, or t into ds is equal to what we are getting here, mc dt. So if we integrate this, we need what is change in entropy, that is ds is equal to mc dt over t. So if we integrate this, what we will get over here, look at over here. So integrate this from process S1 to S2, and over here temperature is changing from T1 to T2. So we'll get change in entropy is nothing but S2 minus S1. This is change in entropy is equal to mc is the common term, and what we'll get dt over t, and here it is T1 to T2. So final expression what we are getting over here, S2 minus S1 is equal to mc mass of that water or mass of that ice, and if you integrate this ln, you will get T2 over T1, T2 by T1. So this is the final expression that we are getting from what will be the change in entropy for both the systems, for case 1 and case 2. You can easily find out, but the question is, I need what is the entropy change for both the systems for at I say ambient temperature T0 is equal to 25 degrees Celsius. This is my room temperature or ambient temperature. So again the interviewer can confuse you in the state, because you can see here you will get change in entropy in that case, but if I am saying I need or you can tell me what will be the entropy at the room temperature. I have asked you that question, what will be the entropy at 25 degrees Celsius, or what will be the entropy at room temperature, or if they can ask what will be the temperature at particular temperature, what will be the entropy at particular temperature. So no need to confuse over there. So you can assume assumption like at 0 degrees Celsius, you can assume a reference at T0. If my T0 is 0 degrees Celsius, that case my entropy will be 0. So that reference you have to be assumed. So that is very important thing in the interview. You need to take a reference, some reference, so that you can proceed to the solution. You have assumed for particularly 0 degrees Celsius my entropy is 0. You can find out a change in entropy from this equation if a solid body is there or a liquid substance is there, but you need a point function or at a particular state of a point, because entropy is again a point function. you can find out entropy is a property. For that property, for particular temperature, you can easily find out what will be the change in entropy or what will be the entropy at 25 degrees Celsius. So I have assumed that for 0 degrees Celsius my entropy is 0. That reference you have to assume. This is a very important thing. And again, for if what will be the entropy at T naught, if my T naught is changes to 25 degrees Celsius, what is my entropy? And that case you need to find out, that is S2. S2 will be the entropy for that case. So what you can take, this is S1 is 0. We have assumed some reference. So S2 is equal to m mass of the substance into specific heat. C value for liquid or C value for solids are constant. That is not going to change. In case of gases, that value is going to be vary. But here C value for water, C for water we know 4.184 kilojoule per kg Kelvin. That is value of C. So C into ln T2 over T1. My T2 is going to change is, it is in Kelvin, 298 divided by 273. This value T2 over T1 is, you have to take that value in Kelvin. 25 degrees Celsius or 30 degrees Celsius is given, then that will be 273 plus 27, 300 or 25, whatever is the room temperature is given, that you have to take into consideration, and 273 the reference. So S2, what is the entropy for water having liquid at room temperature? So S2, this will be the entropy for S2. You can find out MCLN 298 by 273. C value is 4.184 kilojoule per kg Kelvin. So no need to be struggle in that case. You need to be consider the any reference. You need to consider this reference at 0 degree Celsius. My entropy is 0. Then what will be my entropy at a particular room temperature? That is 25 degrees Celsius. If they can ask you what will be the change in entropy, it will be very easy to find out S2 minus S1. Now the first question we will going for the, in both the cases, which entropy is higher? If I ask you further question, which entropy is higher for case 1 or case 2? So you need to think on that. What is the entropy? Entropy relates degree of randomness or disorderness. So which case having maximum disorderness or randomness? You can think over the solid ice, crushed solid ice having a disorderness is very less or randomness of a molecule is very less, because force of intermolecular attraction between the bonding between the molecule is very tight. In case of solids, that we know, liquids, the intermolecular force of attraction is going to be negligible, or it is going to be very low as compared to solids, and gases it is very negligible. So in that case, gases having a maximum disorderness or randomness, so entropy for gases is very high as compared to solids, as compared to liquids. But in both these cases, entropy for a solid or degree of randomness is a very low as compared to liquid. So which case having maximum disorderness? So case number 2 having maximum disorderness. So case 2, that is having maximum disorderness. So for entropy for case 2 is high. We can say glass of water having higher entropy as compared to your crushed ice, because crushed ice having a less degree of randomness, a less or we can say less disorderness, so entropy will be a less. So again, maximum is the disorderness, maximum is the entropy, maximum is the randomness, and that is the concept of your total entropy. So I think it will be very helpful to you, this kind of video lecture series, and we are going to further take a very good conceptual questions for interview questions for BARC, DRDO, ISRO. So if you like this lecture series, please do comment, or if you want to take any kind of help, you can post a comment for a particular question. We'll give you or we'll upload you solution for that interview question. So thank you very much.